I'm Anil Kumar sharing with you an excellent question on area of segment and sector. The question here is, the diagram below shows a circle of radius OA 5 centimeters. The angle AOB is 135 degrees. Find the shaded area. That means area of this segment, right? So that is called the segment. The portion which is shaded here is called this segment. So you need to find the area of this segment. How are you going to find? Pause the video and then answer the question. The strategy here will be that area of segment is equals to area of sector minus area of triangle, right? So that is how you can find area of this segment. So what we have to find first is that the area of, what is the area of the whole sector? That means this area. Do you understand? The whole thing. So that becomes the area of the sector. That means we have to find the area of this whole thing, and from here we have to take away the area of the triangle, which is that much, right? So what we are going to be left with is the area of the segment. You get the idea. So that is the strategy, right? So in this particular case we are given the angle in degrees, so we'll work in degrees. And now let us find area of the sector first. Area of the sector can be found from the ratio of total area of the circle. It's a part of that. Now here this angle is 135. So let me write this angle as 135 degrees. So total angle is 360 degrees. So we say area of circle is equals to pi r square, correct? So which in this case radius is 5, so let me write this unit as 5. So both are 5. You'll see that is an isosceles triangle, correct? Both are the radius. They are 5 units long. So area of the circle is pi r square. We'll first derive the formula and then we can always calculate. Now out of that total area, the sector which we are interested is for the angle of 135. So we can say area of sector is equals to the ratio of total area of the circle, which is pi r square, times 135 degrees divided by 360 degrees, right? So the concept is the whole area is divided to small angles, right? And then out of which the ratio 135 over 360 gives you area of the given sector, correct? Calculate the answer now. So it is 135 divided by 360. So that is the ratio, and the area of the circle was pi r square. So we'll multiply this by pi and then with r square, which is 5 square, and that gives us 75 over 8 pi. Let me write it in decimals. So it is around 29.452. Okay, let's take this value. So the area is 29.452 for the whole sector. Now we need to find area of the triangle. Now how to find area of this triangle? So for that, let me make a bigger triangle, the same thing, so that we can understand how to find this. So we have given this triangle here, and it's an isosceles triangle, correct? So to find the area, we can drop a perpendicular like this here, right? So let me drop a perpendicular from here. Now since this is an isosceles triangle, these sides will be equal and the angles will also be equal, correct? So what we have here is that each angle will be half of 135, right? So half of 135 is 65.5, right? Let's do it. 135 divided by 2 is 67.5. So let me write down this as 67.5. I mean 67.5. So each angle is 67.5. Area of a triangle is, so let's write down area of the triangle, which is half base, which is AB for us. So in this case AB, base, times height. Let's say this is P when we drop the perpendicular, times OP. So this is O, A, B, and that is P for us. So that is how we can find the area. Now AB is equals to 2 times AP, correct? So because these two are equal, and we can find that side AP using trigonometry, right? So we have hypotenuse as 5. This is the opposite side, correct? So AP is equals to how much? So let me write down here. AP is the opposite side of 67.5. So it is 5 times sine of 67.5. Similarly, OP is the adjacent side of the triangle, right triangle. So OP is equals to 5 times cos of 67.5. So that is how you get both the sides, correct? Right? I hope you remember. What is cos of this angle? Cos theta is, let me write, okay, I think you get it. So, you know, cos theta is 67.5 is adjacent side OP over OA, right? So when you cross multiply, you get OP. OP is OA times cos theta. Similarly, you can find the other side. So these are my sides for the given triangle. Now, this length is 2 times AP, so I could write this as half of AB as 2 times AP, correct? Times OP, correct? So 2 and 2 cancel, so it is AP times OP. Let me write here, AP times OP. Okay, so that means product of these two sides, right? Now, AP times OP is the answer. Now what is AP? AP is 5 sine of 67.5 and OP is 5 cos 67.5. I'm purposely writing it like this so that some of you can understand. You remember the formula 2 sine A cos B, correct? So you could use 2 sine A cos B here. Sine 2 theta you get in terms of sine 135 degrees, right? At present, actually, you can just find these two sides, multiply, and you get your answer there and then, right? So we are close, but I'm going an extra step here and writing this as, we can calculate and find the answer also at this stage. Let's do that part, and we'll add those things later, right? So we have 5 times 5 is 25. Let me write 25 times cos of 67.5 times sine, oh I pressed, okay, that's fine. So 25 times cos of 67.5 times sine of 67.5, right? And that gives us the answer 11.597. Okay, so that is what you get, right? 11.597. Well, some of you can see that we could have worked with 135 degrees also, r theta, okay? Fine. Now we know the area of the sector and we know the area of the triangle, so we can find area of the segment. So we get now area of segment equals to difference of these two. That means 11.597 minus, I wrote it the other way. Okay, so it should be, this is minus and that one is plus, 29.452. Okay, so that is plus. Okay, so I should have written this minus this. Anyway, so now you get it.